Okay, so yesterday we worked on dividing polynomials. We looked at long division, and then we looked at synthetic division. So I just wanted to remind you real quick on synthetic division. Remember that we put the 0, the divisor, right here in the what I call the box, and then we multiply here. We bring down the 3 first. We multiply here to get a -9, and then we add. We multiply to get the 27, and we add, and we just keep going. And then your last one here, the 223, this is your remainder. And so if I've got a quartic function and I'm dividing by a linear, then my answer would be a cubic. Okay, x to the 4th divided by x gives me x third. So we would start with x cubed here. And so this would be x squared, this would be the linear term, this would be the constant, and then 223 would be your remainder, which we write as 223 over the divisor, which is x plus 3. Okay, so now we're going to use synthetic division today. We're going to look at two different theorems, which are pretty cool. The first one is the remainder theorem. So let's look at that real quick. The remainder theorem is really easy. If we go back to that numerator of the f function above you, then I'll just use the 3x to the 4th minus x squared plus 2x minus 5. The cool thing about the remainder theorem is you can use, usually we would use function notation. We could plug in something like -3 right here and plug that in for x all the way. But in our example above, if you look, we had a -3 in the box and we got 223 as our remainder. If you were to work through this problem down here, you would see that you would get that remainder right there if you plugged in a -3. And that's the remainder theorem. So you can use function notation like you've always used it, where you can find f of any number and just plug that value in for your input, or you can use synthetic division to figure out what that output would be. Let me show you real quick. Let's say that you want to find f of 2. Well, like I said before, if you want to plug in that 2, you can do so. Or we can just put 2 in the box like this. Write out your coefficients. So 3, don't forget the 0, -1, 2, and -5. Bring down to 3, multiply, add, multiply, add. Keep going. So my remainder is 43. So that means that f of 2, whatever's in the box there, equals 43. Okay? So sometimes that can actually be quicker, but more than anything, it's just another method to plug in an input and get an output. So that's remainder theorem. We'll spend a lot more time on factor theorem. So let's look at that. All right, so factor theorem. The definition says this: if x minus a is a factor of the polynomial p of x, then p of a, meaning that value right there, if I plug it in, then p of a equals 0. In other words, you have no remainder. Okay? Let me show you here. Let's take something like 12. If I asked you what some factors of 12 were, you would say 2 and 6. You would say 3 and 4. Well, the reason that we say that 3 is a factor of 12 is because it goes into it 4 times evenly with no remainder. Okay? So if you're just talking about the factor theorem, you would say that 3 is a factor of 12 because I get 0 as my remainder. Okay, so we're going to do the same thing with polynomials. So let's do this. This would be my second example, so we'll just call this example 2. The question is x minus 2 a factor of function f 6x cubed minus 19x squared plus 16x minus 4. And let's take it a step further. If so, if it is a factor, then let's write f of x in factored form. Okay? So is x minus 2 a factor? So we would take, if this is x minus a, we would take 2, put that in the box, write out your coefficients, 6, negative 19, 16, and negative 4. Bring down the 6, multiply, add, multiply, add, multiply, add. So because we get 0 as our remainder, that means that, yes, x minus 2 is a factor. Okay, it goes into it evenly with no remainder. So now we can say that, let's start with the original. Let's say that 6x cubed minus 19x squared plus 16x minus 4. If we're going to factor that, now we can say that x minus 2 is a factor. Let me roll that up. There you go. X minus 2 is a factor, and we have 6x squared minus 7x plus 2. Now the question is, can we continue factoring this quadratic? So multiply a times c, 2 factors of 12 that add up to a negative 7. Divide by a, reduce, and add x on the bottom there. So our final factored form of the f function here would be x minus 2 times 3x minus 2 times 2x minus 1. So we just use synthetic division in the factor theorem to take that difficult cubic and factor it all the way down to these 3 linears here. which we could go from there. You know, we could graph, we could find our zeros, we could use the fact that there's no multiplicity, think about end behavior, all the things that we've been working on lately. All right, let's look at another. Actually, I'm going to flip this over because I think I'm going to need more room. There you go. Let's divide P of x equals 8x to the fourth minus 16x cubed plus 16x squared. Oh, I'm going to run out of room. Minus 27x plus 18. Got all that? Let me slide it. There you go. Sorry, it's an ugly 18. We're going to divide that by 2x minus 3. So find your 0 here. So x would equal 3/2. And let's put that in the box. Write out your coefficients. So 8, negative 16, positive 16, negative 27, and 18. Then we'll multiply, add all the way across. So bring down the 8. We get a 24 over 2. We get a negative 12 over 2. We get a 30 over 2. And we get a negative 36 over 2. And we end up with a remainder of 0. So, what I want to show you here, well, let's go ahead and write this out. This is what we have so far. X minus 3/2 with 8x cubed, because we have a quartic divided by a linear, so now we're dealing with a cube here. 8x cubed minus 4x squared plus 10x minus 12. Now notice up here we divided by 2x minus 3, but here I've got an x out front because of that minus 3/2. If you want that a 2x and it'll get rid of the fraction, you can just factor out the 2 here. Let me show you. Factor that 2 out, so we get 4x cubed minus 2x squared plus 5x minus 6. Now that 2 can multiply into here. So we can write that 2x minus 3 as a factor. Again, the only reason I just showed you that step is because if you wanted to write the 2x minus 3 as a factor, just using the factor theorem. But I do want to go over just the fact that we got no remainder here. That tells us a lot about these polynomials. So let's write out some information that we just figured out. Let's see. What does no remainder tell us? No remainder tells us that 2x minus 3 is a factor. Which also tells us that 3/2 is a 0 or a root, which means that 3/2 comma 0 is an x-intercept. And then also go back to remainder theorem. F of 3/2 is 0. So there you have it. That is remainder theorem, which is really simple. Just another option to use. Instead of just plugging in a value, you can just quickly use synthetic division and get the remainder as your answer. And then factor theorem, the whole thing is just based on whether or not your remainder is 0. And if your remainder is 0, then you can use that to continue to factor and also get all of this information about your graph. So there you have it. I hope you guys have a great day. Your assignment's on the board, and I will see you tomorrow. Thanks.